Welcome to The Explainer. So today we're diving into what is honestly one of the most absolutely crucial challenges in modern tech right now, and that's how to keep our personal data entirely private, while still getting to use the massive game-changing power of AI. We are going to walk through exactly how to build a completely offline, ultra-secure AI vault.
I want you to think about this for a second. Would you take a highly sensitive document like, say, your detailed medical file, your personal tax returns, or maybe a top-secret proprietary company roadmap, and just feed it directly into a public AI on the internet? Yeah, probably not. Because the minute you hit submit, you literally have no idea which future large language models might be actively training on your most intimate data. The stakes for privacy are incredibly high here. But on the flip side, we don't want to just miss out on what AI can do for us, right? So how do we actually get the best of both worlds? Okay. Let's dive into this. Think of this as our architectural blueprint for today. We're going to break down this dense topic chronologically. We'll start with the privacy problem, then define what local RAG actually is. From there, we hit the three main phases: ingesting data, vector embeddings, and smart retrieval. And finally, we'll look at the proof that this works and what you can build next.
Part 1. The privacy problem. Look at your personal data as a vault. It's a vault that needs protecting. With public LLMs, an internet connection is required, which essentially means you're surrendering control of your data to their continuous, massive training pipelines. But the alternative? Running a local model. This is the ultimate solution because it's 100% offline, it's totally air-gapped. You get total privacy because your data literally never leaves your physical machine. Part 2. What is local RAG? Chat with private data. So, to unlock this vault, you need a key, and that key is RAG. RAG stands for Retrieval-Augmented Generation. Now, in practice, what this actually means is we're bridging the gap between an AI static, baked-in training data and the fresh, highly secure local PDF sitting right there on your hard drive. It lets you chat with data the model has never laid eyes on. It's kind of like giving the LLM an open book test, but it's only allowed to use the highly secure private library that you provided.
And the really cool part is that building a local RAG pipeline isn't some rigid, unchangeable structure. It's way more like swappable Lego bricks. We use Ollama to run the models locally, LangChain to orchestrate all the complex tasks, and ChromaDB as our vector store. And for the actual brain of the whole operation, well, you can just hot swap models like Mistral, Gemma, or Llama 2, really depending on what your specific machine's memory can handle. If one brick doesn't quite suit your hardware, no worries. So you just pop it out and snap another one right in.
Part 3. Phase 1. Ingesting data.
Let's get into the technical blueprint. Right now, we're focusing on step 1, ingesting the PDF. To really prove this system works on entirely unseen data, we're using a 26-page document straight from the World Economic Forum, published in January 2024. Using LangChain alongside a super handy tool called unstructured.io, our Python script effortlessly extracts all the raw text. I mean, think about it. That's something that would take a human quite a while to parse through manually, but the code just handles it in mere seconds. But here's the catch. An AI can't just swallow a 26-page book whole in one single giant bite. It needs it in bite-sized pieces. So we recursively slice our document into smaller chunks of exactly 7,500 characters. But there's a risk here. If you just take a pair of scissors and hard-cut paragraphs right in half, the AI entirely loses the context. So we intentionally build in what's called chunk overlap. Imagine reading a book where the bottom of one page repeats the exact same sentence as the top of the next page. That overlap acts as a bridge. It ensures a coherent connection between the chunks, so our AI never suffers from what we call the lost in the middle problem. It keeps its train of thought perfectly intact.
Part 4. Phase 2. Vector embeddings.
Okay, so with our PDF successfully ingested, we shift squarely into the second phase of our roadmap. Step 2, embed and store. We're translating human text into computer logic here. To actually make all this text searchable, we have to map our human-readable chunks into a dense vector space. Think of it as a massive, multi-dimensional matrix of coordinates, just zeros and ones. We're using an embedding model called Nomic Embed Text for this, specifically because it's incredibly fast, high-performing, and it boasts a massive context window perfectly sized to handle our chunks. So once Nomic translates our text into math, those vectors are loaded into a highly organized folder inside our ChromaDB database. We simply name this collection Local RAG, and boom, our private vault is now fully stocked.
Part 5. Phase 3. Smart Retrieval.
We've finally reached the finish line of our pipeline. Step 3. Retrieve and ask. This is where the magic actually happens, and you get to query the AI. Now, what's really interesting about this slide
is what happens when you ask a simple question like, "What is this document about?" The system doesn't just do a basic, boring keyword search. No, using LangChain's multi-query retriever, it dynamically generates 5 different, slightly varied versions of your prompt, completely behind the scenes. It literally outsmarts the system by asking things in different ways, casting a much wider semantic net into our vector database to guarantee we don't miss anything crucial.
Once those 5 different searches grab the most relevant data from the database, the system takes the union of all those answers. It packages up the absolute best context and then hands it over to a strong local model like Mistral. By feeding Mistral this perfectly curated summary context right alongside your original question, it guarantees a highly accurate synthesized response based only on your vault. This virtually eliminates any chance of the AI hallucinating or just making things up.
Part 6. Proof and what's next. So, does it actually work? Well, when we asked the system to identify the core themes of the document, the completely offline Mistral model perfectly extracted this quote from the World Economic Forum's test document. The 5 pillars of global cooperation are trade and capital, innovation and technology, climate and natural capital, health and wellness, and peace and security. It got it entirely right. It pulled deep, highly specific insights out of a 26-page document in seconds, entirely disconnected from the web. That is the proof right there.
So the real question is, what will you build next? You could wrap all this command line code into user-friendly Streamlit web app, where you just click upload and chat right within a beautiful interface. Or, you could dive into advanced agentic RAG. Imagine actually assigning an autonomous AI agent to every single document you own. You now have the blueprint. You understand how the Lego bricks snap together. The private, highly secure, totally offline AI world is completely open to you now. So, what vault are you going to build tomorrow?